Hey everybody, welcome to the Knight class once again. This is Coach Knight. We're going to go over our Chapter 3 review today. I'll try to go as slow as I can and hopefully answer any questions you might have for the test that's coming up. Number one, we'll just get right to it. Number one says the graph is a portion of a graph, complete graph. Sketch the complete graph assuming it is symmetric with respect to the y-axis. All that means is we're going to flip it over the y-axis, so you should draw a line that looks something like that, and you're done. Number two, is the following function an even function, an odd function, or neither? You look at all the exponents. If they're all even, it's even. If they're all odd, it's odd. And if you have both odd and even exponents, then it's neither. So in this problem, you can see that we have a 6, which is an even number, a 2, which is an even number. And when it's just a number, that means it's 0 for the exponent on your variable, because there is no variable. And all of those are even, so it is an even function. And that's all there is to that. Number 3, this number should look very familiar. You've seen it many times. It was on your last test as well as your last review. This absolute value function has moved 1, 2, 3, 4, 5 to the right and down 1, 2, 3. So the equation for that will be the absolute value of x. Since it moved right 5, we're actually going to subtract 5 because everything's opposite in the absolute value. That moves it horizontal. And then it went down 3, so we put minus 3 on the outside. And that is all there is to that. Number 4, you have to graph. I don't mind if you use your graphing calculator to help you do this. I don't happen to have one with me, so I have to do it the long way. And you need to know how to do it the long way anyway as well. So just make me an XY plane, make you a table, and the first X that you're going to plug in, you're going to have to find the axis of symmetry, which is negative b over 2 times a. So that will be negative b in this problem is 4 over 2 times a is 1. So it's ax squared plus bx plus c. So there's where my a and b are coming from. That reduces to x equals negative 2. To get your y, you plug it in. 2 squared plus 4 times, negative 2 squared plus 4 times negative 2 plus 3. That will be 4 minus 8 plus 3, which is negative 1. So that is my first point. That is my vertex, negative 2, negative 1. Then this is just the Coach Knight way of doing things. I plug in 0 from my second point and double the first one to get my third x. Okay, that's just how I do it. That way I'm going 2 to the right of negative 2, which is 0, and 2 places to the left of negative 2, which is negative 4. Plugging in 0 makes it very easy to plug in. The x squared cancels, the 4x cancels, and you're just left with 3. And then when you plug in negative 4, you will also get 3. So 0, 1, 2, 3, and 4, negative 4, 1, 2, 3. So there are your 3 points. This is a greater than, just greater than. So since it's not equal to, I do a dashed parabola. And since it's greater than, I shade up. So I shade above it. Okay? And that's all there is to that. On the next page, number 5, says given that f of x equals x minus 6 squared plus 7. Find the inverse of x, then state whether the inverse of x is a function. So to find the inverse of x, I'll put it over here. You're going to switch x and y. So we're going to say x equals y minus 6 squared plus 7. And then you solve that for y. So I'll subtract 7 from both sides. X minus 7 equals y minus 6 squared. Take the square root. Take the square root. That will be plus or minus the square root of x minus 7 equals y minus 6. And for your final step, you just add 6 over to both sides. And that is your inverse. So the inverse of f of x equals 6 plus or minus the square root of x minus 7. Now, as far as state whether that's a function or not, my original problem was a quadratic, which means it's going to look like a parabola. And if you were to draw a horizontal line and do the horizontal line test, you see that it touches the graph twice, which means the inverse would not be a function. So not a function. Okay. 6 and 7, we talk about discontinuity. Remember, we talked about 3 types of discontinuity. There was infinite discontinuity, jump discontinuity, and point discontinuity, or it could be continuous. So, infinite discontinuity. Infinite is the kind, I'll write it over here, infinite equals asymptotes. If it has asymptotes, it has infinite discontinuity. Jump looks usually, jump is when it's like a piecewise function. It looks something like f of x equals, we'll say, negative x plus 1 when x is greater than or equal to 2, and negative 2x minus 3 when x is less than 2. That would be an example of what it would look like if it were jump. Point discontinuity. It's point discontinuity when you can cancel a variable out. And this number 6 is actually point discontinuity, and I will show you why. So, on the top, there's a little factoring needs to be done. So I can factor out an x on the top. So that'll be x, and then it leaves me with x squared minus x minus 42. Over x plus 6. Because right now I can tell, I think it has a vertical asymptote right here because it's got a variable on the bottom. So normally we would say, hey, it's got a vertical asymptote at x equals negative 6. But if I keep going and I factor this out, I can factor one more time to factor that trinomial. I need 2 numbers that multiply to be negative 42 and add up to be negative 1. So 2 numbers that multiply to be negative 42 and add up to negative 1 are negative 7 and positive 6. And now you can see that x plus 6 and x plus 6 are the same thing, so they will cancel. If it cancels, that's what makes it point discontinuity. Okay? Otherwise, it would have been infinite discontinuity. Okay? So I hope that helps explain things. Again, if nothing cancels and there's a variable on the bottom, chances are it's going to be infinite discontinuity. If something does cancel after you factor it, then it is point discontinuity. Number 7 is actually continuous. simply because you're not dividing by any variables. You're just dividing by 2. So nothing's going to change. You can just divide by 2 and go on about your day. That doesn't have any asymptotes. There's no point that's holes. And it's definitely not jump. Okay? 8, 9, 10, 11, and 12 will all look the same as far as the start. They will all say, as x approaches negative infinity, f of x approaches something, and as x approaches positive infinity, f of x will approach something. We just have to figure out what the something is. So these are the ones where we plug in infinity. Well, we'll plug in negative infinity. So if I were to plug in negative infinity here, 3 times negative infinity cubed. Negative infinity cubed is still negative infinity, so times 3 would be negative infinity. So as x approaches negative infinity, f of x approaches negative infinity. Now we do the same thing with positive infinity. 3 times positive infinity cubed would just equal positive infinity. So this one would be positive infinity. And remember, I told you, if it's an odd exponent, these should be going to opposite infinities. Okay? Now they might change, but if one's going to negative infinity, the other one needs to be going to positive infinity if the exponent is odd. Okay? So 9, same start. As x approaches negative infinity, f of x will approach something. As x approaches positive infinity, f of x will approach something. So, again, you're only worried about the biggest exponent, so don't even worry about what's behind it, okay? It's an odd exponent, so I know that these two should be opposite each other. One's going to be going to positive infinity, one will be going to negative infinity. We just have to figure out which one. So if I plug in negative infinity to the 5th, that stays negative, so that'll be negative infinity. So again, I'll put negative infinity. If I plug in positive infinity, that will stay positive infinity. So, again, notice one's going to negative, one's going to positive. Why? Because we had an odd exponent. All right. Number 10, again, same start. As x approaches infinity, as x approaches negative infinity, f of x will approach something, and as x approaches positive infinity, f of x will approach something. So here we go, plugging in. The one with the biggest exponent would be your negative x cubed here, so don't worry about the rest of it. You're just plugging in this part. So if I plug in negative infinity, negative times negative infinity cubed, that will equal negative times negative to a cube stays negative. And what's negative times a negative infinity? Positive infinity. So this time when we plug in negative infinity, we get positive infinity. And if we plug in positive infinity, negative times positive infinity cubed, we just get negative infinity. Again, one more time, the rule holds. Odd exponent, one has to be positive, one has to be negative. Every time. Okay? Last two. Again, look for the highest exponent. That's 2x to the 4th. Don't worry about the plus 1. And again, we're starting off as x approaches negative infinity, f of x will approach something. And as x approaches positive infinity, f of x will approach something. Okay? So, if I plug in 2 times negative infinity to the 4th. A negative to the 4th power becomes positive, so that will just be positive infinity. And 2 times positive infinity to the 4th will also just be positive infinity. So here's our other rule. If you have an odd exponent, your f of x's will be approaching opposite infinities. One will go to infinity, one will go to negative infinity. But if you have an even exponent, they will be approaching the same infinity. They might both approach odd negative infinity, or they might both approach positive infinity. Number 12, again, highest exponent is negative 5x to the 3rd, so it's an odd exponent. So they're going to be approaching opposite things. As x approaches negative infinity, f of x will approach something. As x approaches positive infinity, f of x will approach something else. We know they're going to be opposites. We just need to know which one's which. So again, don't worry about the 4x. Just concentrate on the one that's the biggest. So negative 5 times negative infinity cubed. Negative cubed would stay negative, and a negative times a negative 5 would be a positive infinity. And then finally, negative 5 times positive infinity cubed. Well, positive infinity cubed is positive infinity times negative 5 would be negative infinity. So, as you can see, there are quite a few of these. That's what, 1, 2, 3, 4, 5 of these problems. So please know how to do these, okay? I know it says without graphing, but I do not mind if you use your calculator and graph them to check and make sure you got it right. You just have to look and see how the ends, where are they going? If the end is going up, it's approaching infinity. If it's going down, it's approaching negative infinity. Okay? Number 13. Find the relative minimum and relative maximum points for the graph. This is calculator problems. 13 and 14. Calculator. Okay? These are the ones where you have to do the left bound and the right bound, and it will find it. So let me see if I have my calculator on my iPad here. Let's see here. There it is, calculate 84. So if I go to y equals and I type in, I forgot what it was. Let's see here, x to the 3rd plus 6x squared plus 9x plus 8. So x to the 3rd plus 6x squared plus 9x plus 8. I want to make sure that's right. One more time. All right, that's correct. And we hit graph. As you can see, there's my graph. I'm going to zoom 6, make it regular. All right. So I can tell there is a maximum here and a minimum. A maximum's on the left and a minimum is on the right. So you hit second trace. The maximum was first, so I'm going to hit 4. And I move my cursor. It asks for the left bound, so I move my cursor to the left of the maximum, enter. Then I move my cursor to the right of the maximum, and I hit enter. And I hit enter one more time, and it tells me that is not right. I think I hit enter one too many times. You'll have to hit enter 3 times. I don't think I had to do that. So let me try this again. Second trace, maximum, go left, enter, right, enter. Okay, and there's the maximum. It says it's -3, or negative, excuse me. Yes, -3, -8. Excuse me, -3, +8. -3, +8. That is my maximum. Let me see if that's right. I'm not sure if I'm trusting this. -3, -8. Oh, yes, it is right there. -3, -8, or -3, +8, excuse me, was my relative maximum. So relative maximum, -3, +8. I have a relative minimum. Let's go back to my calculator and let's see. So I hit second trace, go to minimum this time, which is number 3, left bound. So I go left. I know there's my minimum somewhere, so I need to go left of that, hit enter, go right of it, hit enter. And again, you'll have to hit enter one more time, but mine, I don't have to do that. So it is -1, 4 is my minimum. So -1 and 4. Okay. That's everything I can do to say any questions, but I know you can't ask them. If you do have any questions, you can message me on Remind, and I will do my best to get back to you. 14. Do the same thing. We have a different equation here, so I'm going to go to y equals, excuse me, and we'll clear that one out. And let's see, my equation was x to the third minus 3x squared minus 4. So x to the third power minus 3x squared minus 4. Double check, just make sure that's right. It is. And so here I go. Graph. All right, it looks like it has a maximum and then a minimum. Maximum's around there somewhere, minimum's around here somewhere. So I'm going to try to find the maximum first. Hit second trace, go down to number 4, or just hit 4. Go to the left of your maximum, hit enter. Go to the right, hit enter, and I have a maximum at 0.000004, which is just 0.4, and -4. So I have a relative maximum at 0, -4, and I have a relative minimum. Let's see where this relative minimum is. I do the same thing, second trace, go to number 3, relative minimum, make sure I'm to the left of this point, so enter, then go to the right of it, enter, and I have a relative minimum at 2, -8, it says. So 2, -8. So again, both of those problems, 13 and 14, entirely done on your calculator. Okay. 15 and 16, you are finding your vertical, horizontal, and slant asymptotes, if there are any, for the function. Now, as I told you, you will never have all 3 at once. Okay. You can only have 2 at a time. So if you will remember, when the exponent is bigger on top, there is not a horizontal asymptote. So this one, you have x to the third on top, x squared on the bottom. Therefore, you do not have a horizontal asymptote. If to be a slant asymptote, the one on top has to be exactly one number bigger than the one on bottom. So we have a 3 on top and a 2 on the bottom. 3 is 1 bigger than 2, so we do have a slant asymptote, and we have variables on the bottom, so that means we are going to have vertical asymptote as well. So to get our vertical first, it's the easiest. I need to factor the bottom, so that's going to be x, and I need 2 numbers that multiply to be -4 but add up to be -3. Well, that's -4 and +1, and so I have vertical asymptotes at x equals -1 and x equals +4. Do not forget to put x equals. Remember, this is a line, so you got to write an equation for it to be correct. So you have to put the x equals. Okay? To get the slant, you have to do long division. So I'm going to do my long division. That was, let me clean this up a little bit, make it a little wider. All right, so long division, we've got x squared minus 3x minus 4 and 2x cubed minus 9x squared plus 2x plus 16. All right, so we don't need those factors anymore. Okay, so ask yourself, what times x squared gives you 2x to the third? And hopefully your answer is 2x. And we distribute this 2x to everything down here, okay? So 2x times x squared is 2x to the third, but remember you do the opposite, so it's minus. 2x times negative 3x is negative 6x squared, but remember you do the opposite, so it's plus. 2x times negative 4 is negative 8x, and again it's the opposite, so you do plus. And then you add those up, you'll get negative 3x squared plus 10x. Bring down your 16. Then you ask yourself, negative x squared times what gives you negative 3x squared? And the answer to that is simply negative 3. Now technically you can stop here, but I'll keep going just to show you. That would be negative 3x squared, but we do the opposite, so it's positive. Negative 3 times negative 3x is positive 9x, but again, you do the opposite, so it's minus 9x. And then negative 3 times negative 4 is positive 12, but we do the opposite and you get negative 12. So I'll have a remainder of 4. Again, you don't need the remainder. There's your answer up here at the top. Y equals 2x minus 3. That is your slant asymptote. Okay? We do the same thing again on 16. Again, there is no horizontal asymptote because the one on the top is bigger than the one on the bottom. Remember, if the one on the bottom is bigger, your horizontal asymptote would be y equals 0. And if they are the same, it's just y equals whatever those coefficients divided by each other are. But it will probably be like the ones on your review on your test. Hint, hint. So let's find our vertical asymptotes first. Again, I'm going to factor what two numbers multiply to be 3 and add up to 4. That would be positive 3 and positive 1. So I have vertical asymptotes at x equals negative 3 and x equals negative 1. And then for my slant, it will be y equals, and again I'm going to come over here and divide. I think I got enough room over here, so we're going to have x squared plus 4x plus 3. And we're going to take that into 2x cubed plus 14x squared plus 31x plus 24. And again, you ask yourself, what times x squared gives you 2x cubed? And just like last time, it's 2x this time. So 2x times x squared is 2x cubed, but you subtract 2x cubed. 2x times 4x is 8x, but again, we subtract 8x squared. I said 8x, but I meant 8x squared. 2x times 3 is 6x, but we subtract 6x. And then we add them all up. So those will cancel like they're supposed to. 14 minus 8 is 6x squared. 31 minus 6 is plus 25x. Bring down your 24. And you play the game again. What x squared times what gives you 6x squared? And this time it is 6. So put a plus 6 at the top. I'm not going to keep going this time because there is my answer right there. 2x plus 6. So y equals 2x plus 6. That is your slant height. And your vertical, not your slant height, excuse me, your slant asymptote. and your vertical asymptote with x equals -3, x equals -1. All right. The last 6 are what we went over in class today when we were talking about our variations. I don't have a lot of room in between here, so I'm just going to do all 3 of them down below here. 17. First, you make the equation. It says if y varies directly as x. So remember, directly means you're multiplying. So y equals k times x. Plug in what you have. You have to find 3 things. You have to find the constant of variation. You have to write an equation. And then you have to solve the equation. So 3 answers for each problem. So 3 equals k times 2 divided by 2. So 3 over 2 is equal to k. There's your first answer. Y equals 3 over 2 times x. There's your equation. And then you plug in, it says to find y when x is 6. So you plug in 3 over 2 times 6, and y will be 9. There is your third answer. And you do that for all 3 of them. So 18, same thing, it's varying directly as x. So same equation, y equals k times x. This time y is 10. Equals k times x is 4. Divide by 4 and simplify. K is 5 over 2. If you put 2.5, that's okay too. Write your equation. Y equals 5 over 2x. And then plug in your number. This time they won't find y when x is 3. So y equals 5 halves times 3, that's just 15 over 2. 19, this time it's varying inversely as the square of x. So remember, inversely means you divide by your variable. So y equals k divided by x squared, because again, it's the square of x. And you plug them in. So 1/5 equals k divided by 5 squared. 5 squared is 25, so 1/5 equals k over 25, and you just multiply both sides by 25. Those cancel, so your k is 25 over 5, which is 5. Then you write your equation. Y equals 5 divided by x squared. Don't forget your x squared. And then they want to know what is y when x is 7. So y equals 5 divided by 7 squared. Y is 5 over 49. Okay. So that's 3 of those problems. The last 3 problems are like these as well. So 6 total problems, 6 out of the 22. That's over a third of them, or not quite a third of them, are these type of problems. So make sure you understand these really good. You have 6 of these, and you have 5 of the end behavior problems. So half of the questions from the test are those 2 things. So make sure you know those 2 things, please. Here we go. Number 20. We're still varying. This time we're varying inversely. Okay. So that means we're dividing. So y equals k divided by, we are varying inversely as x, so it's just k over x. So that will be y, excuse me, what is y? Y is 2/3, so 2/3. Let's try this again. All right, 2/3, gracious. 2/3 equals k over x is 2. To solve for k, we're just going to multiply both sides by 2. K will be 4/3. Then you plug in k, so y equals, it's 4/3 over x, or you could write it a little simpler, 4 over 3x. Just make sure your x is in the denominator, okay? And then plug it in to get, says what is y when x is 5? So y equals 4 over 3 times 5. Y will be 4 over 15. (21). Don't have a lot of room to do 21, so I'm going to do it down here. Again, we're varying inversely as x, so y equals k divided by x. Plug everything in. It says y is 7 over 5 equals k over, it says x is 5. Well, you just multiply both sides by 5 here. The 5's cancel, and you get k is 7. So then you write your equation, y equals 7 divided by x. And then you plug in, it says find y when x is 8. You plug in 8, so y equals 7 over 8. In our last problem, 22, it is jointly. Jointly means you're still multiplying, you're just multiplying by more than one thing. So y equals k. This time we're jointly as x and z, so x times z. Plug in your numbers, it says y is 42 equals k times x is 2, z is 7. 2 times 7 is 14, so we divide both sides by 14. So k will be, let's see here, that's 3. K is 3. Write your equation. Y equals 3 times x times z. And then it says find y when x is 4 and z is 4. So y equals 3 times 4 times 4. Well, 3 times 4 is 12, times 4 is 48. And that is it. So here's all the answers. If you need them, they were in your review. So if you have any questions, you're not really sure how I did something, please feel free to message me, and I will try to get back to you as soon as I can on Remind. I hope this helps, and I hope to be back with you sooner rather than later. Be ready for your test tomorrow, and as always, stay above the line.